Hey YouTube, Booth Dog is here. It is Tuesday, so we are going to jump into our lesson. Right before we do, let's talk about our promotion for today's video. Today's video is sponsored by Calculus. Calculus reached out to me. They heard we were doing such great things with our math lessons, and they couldn't wait to give us a promotion deal. So check the link down below if you'd like to order some calculus for yourself. The promo code is CALC. C-A-L-C, okay, that'll save you 25% off your purchase and get you some free shipping, okay? So Mr. Boothman's going to come on. We're going to go through our lesson for today, and be sure to visit Calculus if you're interested in some more, okay? Have a good one. Good morning. Happy Tuesday. All right, your exit ticket's going to be just like yesterday and last week, asking you some basic questions about today's lesson, so make sure you take care of that by midnight tonight. All right, so yesterday we talked about this idea of a partial sum, and we looked at this really weird kind of new notation for us known as sigma or summation notation. Today we're going to go back to this idea of arithmetic and geometric sequences and look at what partial sums are like for those specific types of sequences. Okay, so let's start with an arithmetic sequence. So the nth partial sum of an arithmetic sequence, okay, well, that's going to be the first term plus, right, here is the second term, plus the third term, since we're just adding that common difference each time, plus all the way to the nth term. Now, we could just sit here and figure out all of these terms and add them together. But if I'm asking you for the 20th partial sum or the 32nd partial sum, that's going to be a lot of work. Okay. Luckily, there is actually a very nice formula for partial sums of arithmetic sequences that allows us to skip over a lot of this work. Okay. And the partial sum of an arithmetic sequence, the nth partial sum, is given by the formula n times the first term plus the nth term, all over 2. Now this formula seems to come from just out of nowhere at first. Okay, it's actually quite a fascinating formula, and if you're interested, join our Google Meet. I'll tell you the whole story of a student many years ago named Carl Gauss. Those of you who go on to study further things in math and physics, you'll hear all about Gauss. But he was one of the first to see this idea, this concept for this formula, while he was just a little kid in school. Quite fascinating. He was quite a prodigy. But this formula, trust me, it comes from somewhere. I'd love to go over it with you later on. But since most of you kind of just want to get on with the lesson, we'll get on with the lesson. So using this formula allows us to answer a question like, find the sum of the first 40 terms of the arithmetic sequence. Okay, the first 40 terms means we're looking for the 40th partial sum. That means n is 40. So what do we need here for this formula? Well, we know the first term is 3. So a1 equals 3. So this is 40 times 3 plus, we need the 40th term. Now to get the 40th term, we need the nth term formula. Okay, so we know the nth term equals the first term plus n minus 1 times the common difference. Okay, so nth term, the first term is 3. And what is our common difference here? 3, 7, 11, 15. So we're adding 4 each time. Using this formula, we can find the 40th term. Okay, simplify all of this, and we get 159. Plugging this into our formula here, 3 plus 159 times 40 over 2 gives us the 40th partial sum of 3,000 240. Okay, so not terribly difficult. And again, this formula is on your reference sheet, so it's not something you have to memorize, but we do need to understand, be able to identify what pieces we need to find so we can finish plugging things in. Okay, we have n, we need the nth term. Okay, that's usually going to be the majority of our work for these types of problems. Let's look at the next problem. Find the sum of the first 50 odd numbers. Okay, well, if you recall, we do have a formula, hopefully you remember, for the odd numbers, the sequence of odd numbers, and it's 2n minus 1. Now, if you don't happen to know that this is the nth term formula for the sequence of odd numbers, then we can find the nth term like usual. Okay, the sequence of odd numbers looks like this. So the first term is 1, and our common difference is 2. And if we simplify this, we do get 2n minus 1. Okay, so that's where this is coming from. Now, if we want the sum of the first 50 odd numbers, that means we're looking for the 50th partial sum. So n equals 50. This is an arithmetic sequence. We're adding 2 each time, so we need the first term plus the 50th term, all over 2. The first term is 1. If the nth term is 2n minus 1, then the 50th term is 2 times 50 minus 1, which is 99. So plugging all of this in, we get 2,500. So again, it's a matter of identifying what we need. Okay, we're given a sequence, we're looking for a specific partial sum, so we fill in as much as we can from our formula, and then we go and find any other pieces that we're missing. All right, example 6. An amphitheater has 50 rows of seats, with 30 seats in the first row, 32 in the second, 34 in the third, and so on. Find the total number of seats. Well, total number means we're looking for some. Okay, we're looking for a partial sum. And if we have 50 rows of seats, that means we're looking for the 50th partial sum. Now we need a sequence here. So if we think of the sequence as the list of numbers that represent the number of seats in each row, okay, then our first term is the number of seats in the first row, which is 30. And then 32 in the second, and 34 in the third, and so on. So this sequence of numbers is arithmetic, right? Our first term is 30. Our common difference is 2. Now, if we're looking for the 50th partial sum, then we need 50 times the first term plus the 50th term, all over 2. That means we need the first term, which is 30, and then we're looking for the 50th term. To find the 50th term, we'll find the nth term formula. This is an arithmetic sequence, so the nth term formula is a1 plus n minus 1 times d. That means the 50th term is 30 plus 50 minus 1 times 2. So if we simplify this, we get 128. Now that we have the 50th term, we can plug that in here, simplify our partial sum, and we get 3,950 seats. So there are 3,950 seats in this amphitheater. Okay. So word problems, same thing. We just need to identify what it is that we're looking for and find all the missing pieces that we need to finish that formula. All right, we're almost done talking about arithmetic sequences, and then we'll spend a little time talking about the partial sums of geometric sequences. How many terms of the arithmetic sequence 5, 7, 9, etc. must be added to get 572? All right, this question's a little backwards. They're telling us what our partial sum is. They're telling us that the nth partial sum is 572. And they're asking us how many terms. In other words, we're trying to solve for n. Okay, so this problem's a little backwards. We're looking for n. We already have our sum. Well, we know that the nth partial sum, in this case 572, equals n times a1 plus an all over 2. Now, we have this sequence, so the first term is 5, and then the nth term is going to be a1 plus n minus 1 times, what's our common difference here? 2. And if we simplify this a little, we get 2n plus 3. So looking at our formula here, we have 572 equals n times a1 is 5 plus an is 2n plus 3 all over 2. Okay, so again, we started with the formula that we know. We're trying to solve for n. We plugged in everything that we can find. Now we end up with this expression, and hopefully we recognize we can just solve this for n. Okay, fairly straightforward equation now. Multiply both sides by 2, so we get 1,144 equals 8n plus 2n squared. I did 5 plus 3, and then I distributed n. N squared, n constant. This is a quadratic equation, so I'm going to move everything to one side. Write this in our normal order. And simplify, factor, use the quadratic formula, whatever you would like. No matter which method you use, you should get n equals 22 and negative 26. So how many terms must be added to get 572? So either we're adding 22 terms, or we're adding negative 26 terms. Now, does adding negative 26 terms actually mean anything? Of course not. We can't have a negative number of terms. So how many terms must be added to get 572? 22. Okay. So that's a good general overview of the types of questions you could see about partial sums of arithmetic sequences. Next, I want to do just a few examples for partial sums of geometric sequences. I know today's lesson's a little longer than usual. I apologize. Okay. So we have a geometric sequence. The nth partial sum is the first term plus the second term plus the third term. Oops, not plus, times. All the way to the nth term. And just like partial sums of arithmetic sequences, there is a nice formula, shortcut, that gives us the partial sum of a geometric sequence. And it's given by the nth partial sum equals the first term times 1 minus r to the nth power all over 1 minus r. So it's not quite as nice as the arithmetic sequence partial sum formula. You're given this formula as well, though. Okay, and really, we're to be able to plug in and answer any questions for this, we just need the first term, r, and then of course n. Let's look at example 8. Find the partial sum of the first 5 terms of the geometric sequence. First 5 terms means we're looking for the 5th partial sum. The first term is 1. We need r to the nth power all over 1 minus r. Now, what are we multiplying by here? If we have 1 0.7, 0.49, 0.343. What are we multiplying or dividing by to get to the next number? Okay, it's geometric, so we're multiplying or dividing. Okay. 1 times what is 0.7? That right there should be a dead giveaway. 0.7. And 0.7 times 0.7 is 0.49. And so on. So what is R? It's 0.7. Okay. Just need to be careful when we're plugging all this into a calculator. We're raising this to the power first, then subtracting it from 1 times a1 divided by 1 minus 0.7, and we get 2.7731. One more example for today. I quite like this example because it's written in such a fun mathematical way. Find the sum looks very complicated at first. Let's break this down. Sigma notation, so we know that we're adding a bunch of terms together. We have the general term, and we're going from k equals 1 to k equals 5. So how many terms are we adding? 1 through 5. So we're looking for the fifth partial sum again. We need the first term. The first term happens wherever we're starting. So the first term is going to be when k equals 1. Okay. Now, k equals 1. If k equals 1, then we have 7 times negative 2/3. 7 times negative 2/3 is negative 14 over 3. So that's our first term here. And it's just given by whatever that is. Then we're multiplying times 1 minus, what is r? Okay. When it's written in sigma notation like this, okay, remember that r is what we're multiplying by each time. So it's what's going to be multiplied repeatedly. In other words, an exponent is repeated multiplication. It's whatever we're raising to a power. So in this case, negative 2 over 3 is our common ratio. So this is r. And we're raising that to the fifth power, all over 1 minus r. And we simplify all of this, and we get an answer of negative 770 over 243. Okay. Please note that if you're following along with the answer key that I posted before, there is a bit of an error in that answer key for this problem. Okay. The first term is not just 7, because again, we have to start where we're told to start, in this case when k equals 1. So that ends up being our first term. That changes our answer a little here. So our answer is negative 770 over 243. All right, so partial sums of arithmetic and geometric sequences, they're just more formulas to use. You're given the formulas, you just need to know how to use them. So homework, please take care of that exit ticket by midnight tonight. Work through some of that 8.2 independent practice. Remember that tomorrow is a work day / retake day, so there is no new lesson or exit ticket or assignment tomorrow. If you'd like to sign up for any retakes, again, I posted that link yesterday, so sign up at that link on Google Classroom. And Thursday, when we pick back up in 8.2, we'll look at a pretty useful topic, especially for those of you moving on to Calc BC, okay? So until then, come to me if you have any questions. Have a great day. Thanks, Boothman. All right, I'll see the rest of you later. Don't forget about that calculus promotion. That ends at midnight tonight. See you tomorrow.